So hi guys, this is Engineer HB and again, welcome back to Derive. So sa topic na ito natin, uumpisahan ng ating journey sa pipe. So pipe stands for Power and Industrial Plant Engineering. So almost finished na tayo sa machine design journey natin. And sa pagkakatanda ko, isa hanggang dalawang topic na lang is matatapos na natin yung machine design. Pero dito sa pipe, sa topic na ito natin uumpisahan, which is the internal combustion engines. Okay, so we will not discuss further details o huhukayin ang topic na ito because this is already discussed on our college days. So, konting understanding lang or definition sa ICE or internal combustion engines is that is an engine where the generation of heat is affected inside the work producing unit. So, the combustor and the work producing unit are the same, and the products of combustion eventually became the working fluid. So dalawang example niyan guys. So that was, kuha lang tayo ulit ng ink. Ayan. So ano-ano yung example niyan? So dalawa yan. So that was the gasoline engine and of course the diesel engine. Okay, so medyo pasmado na tayo magsulat. So ilang months din tayong nawala. Medyo naging busy tayo sa work at sa kung ano pang mga bagay. So as you can see, this is an ICE topic which is ang nakalagay auto cycle. So dalawa daw ang uri ng internal combustion engine which is the gasoline engine and the diesel engine. And obviously nakikita niyo auto cycle, ibig sabihin mag-i-start tayo sa gasoline engine. So konting trivia lang, of course auto or OTTO comes from Nicholas Otto. So malay niyo lumabas sa board yan. Okay, so this auto cycle is the ideal or air standard cycle for spark ignition engines. So commonly known as the gasoline engine. All spark ignition engines are designed for gasoline fuels. So this cycle is a constant volume combustion cycle, of course, named after this person, which is Mr. Nicholas Otto. So let us proceed to the graph. So as you can see, familiar na sa inyo to. So this is just a review only. So karaniwan sa mga power cycles, we are doing the PV diagram, the pressure volume diagram, or the TS diagram. Okay, pero dito, I will just show a one diagram or a single diagram, which is, of course, ang walang kamatayang PV diagram, which is the pressure and the volume diagram. And of course, this is a Cartesian plane habang tumataas. Ito, of course, the pressure increases. At ito, habang umuusod on the x-axis palayo, ibig sabihin tumataas ang volume or nag-expand. Meaning, kapag papunta tayong kabila, paliit, meaning nagko-compress naman tayo. Okay? So let us focus on this PV diagram. Of course, kung nakita nyo is puro graph lang, arrows and numbers. So let us discuss or enumerate the process, the four process that it involves in this graph kasi meron siyang apat na items. So ibig sabihin apat din ang process. Okay? So una muna. So let us label muna this area kasi nasa x-axis tayo. So this is V sub 1. And of course, this is V sub 2. Okay? So, ibig sabihin, ito naman ay, wait lang. So this is of course our pressure 2. And this is our pressure 3. Okay? So ano muna yung 1 and 2? So 1 to 2, the process is called the isentropic compression. So obviously, we are all familiar in this kind of curve pagdating sa PV diagram. Tatlo lang naman ang curve niyan. It's either isentropic, constant pressure kapag horizontal, and of course constant volume kapag vertical. So this is an isentropic compression, meaning from volume 1, okay, nag-compress ka papuntang volume 2. That's why diniscuss ko kanina that when it comes to x-axis kapag papunta doon, so you are expanding, at kapag pabalik ka naman, you are compressing. So since this is an isentropic compression, linawan natin yung arrow. So ayan, meaning from volume 1 to volume 2, meron kang isentropic compression. And of course, dito sa 1 and 2, may nakikita tayong arrow. Ibig sabihin, dito naganap yung work. So, work. Okay, konting review lang. Alam nyo na yung work. Of course, alam nyo na rin yung heat. So, we have an work input here sa 1 to 2. Okay? So, pagdating naman sa 2 and 3, since this is a vertical line, of course, this is a constant volume. Ibig sabihin, kapag ang volume mo dito is 1 cubic meter, pare-pares lang yan na 1 cubic meter. Kasi, nasa isang side ka lang ng volume or nasa isang linya ka lang ng volume. So, obviously, this vertical line represents a constant volume. So, diyan nagaganap ang combustion. At nabanggit na rin natin na diyan nagaganap ang combustion. Of course, may arrow diyan from 2 to 3. So, that represents the Q in. So, sa iba, QA. So, pwede rin Q in. Ibig sabihin, input heat. Or diyan nagaganap yung combustion. Okay? So, how about the point 3 to 4? If your 1 to 2 is isentropic compression, obviously this point 3 to 4 is expansion. So, since this is a curve similar to 1 to 2, so this is an isentropic, and of course, nag-expand from volume 3 to volume 4. So this is an isentropic expansion. And another point to remember, of course, if this is a constant volume is a 2 to 3, ibig sabihin D2 mo is equal to D3. Okay? And of course, the last process is from 4 to 1. So that was the constant volume again because it represents a vertical line. Okay, so meaning if this is constant volume, same ang volume. So meaning V4 is equal to V1. Okay, so dito naman nagaganap yung heat rejection. Okay, so kung may Q in ka doon, of course, meron kang output heat dito. Eh, nakalimutan ko rito sa 0.3 to 4. Kung meron kang work in dito, of course, may lalabas dyan na workout. Okay, so kompleto na. Meron tayong Q in sa combustion. Siyempre yung Q out dun sa heat rejection. Ang combustion and rejection as involve a constant volume process. Siyempre kapag isentropic, ang heat mo dyan ay 0. Kaya andyan ang isentropic compression and asentropic expansion. So of course, it is just a review. So we will move on sa mga formulas. And later we're going to solve a single problem pero maraming branches ng tanong. Okay? So sa heat added naman tayo. So heat added, of course, yan yung Q in. Yan kasi nagaganap yung combustion. Of course, that is where the heat enters. So that was heat added, obviously. So let us represent that again by Q in. Or pwede na rin QA kung saan ka comfortable. So, since this is a heat added, so it has a formula of MC delta T. So ano yung M na yan? Of course, that was the mass. And of course, the C is your CV. So what is CV? That was the specific heat at constant volume kasi nga that 2 to 3 is a constant volume process. So that was MCB. And of course, temperature is involved. That was T3 minus T2, or the difference between the 2 points. So meron na tayong first formula. So we have this so-called network done. Of course, this network done is kung natatandaan natin. So this is the difference between the two works. So dalawa lang naman ang work na involved, which is your workout and work in. So let us represent the network done as W net. So that was the work out. So that was the workout minus work in, or it is also equivalent the difference between these two hits. So that was Q out. No, that was the Q in minus Q out. Okay, so ano pa? So cycle efficiency naman tayo. So cycle efficiency, of course, represented by small e. Of course, it is the ratio of output over input. So that was ang output mo, of course, is your work net, and it is all over Q. Okay. Kasi ang pinasok mo ay itong Q in. Okay, so that was the input, and the output, of course, is the net work done. And in terms of Q, you may write that as a Q in. Sabihin natin QA para hindi na kalito, or isa na lang. So si Q out, pwede natin sabihin sigurong QR para heat rejected. Kasi si A is accepted. So QA. So cycle efficiency of this Otto cycle can be written as 1 minus the ratio of heat rejected over the heat added. Okay. So how about this compression ratio? Of course, compression ratio can be represented as RK. So since this is an SVSV process, what is SVSV? So that was isentropic, constant volume, isentropic, and constant volume. So big sabihin, dalawang volume lang ang involved. It's either B2 is equal to B3 or B1 is equal to B4. So this is an compression ratio, meaning dalawang volume ang involved. So it's either the ratio between B1 and B2. Of course, B1 nasa tuktok kasi mas mataas siya. Andito kasi siya. And of course, B1 is equal to B4 also. And your B2 is equal to B3 also. So how about the heat rejected? So heat rejected natin ay nasa 0.1 and 4. So lagay na natin siya as QR. So QR is equal to MC delta 3, of course. Pero ang mass niya, of course, the same. Ang C niya is specific heat at constant. Ayan, constant volume pa rin. Kasi 0.4 and 0.1 is constant volume. And of course, this delta T is the difference between two temperatures. So that was T1 minus T4. So that was the formula for the heat rejected. Okay. So bakit may efficiency ulit dito? Kasi kapag usapang cycle, bida din lagi dyan ang compression ratio that you can insert inside the efficiency. So we may write the efficiency in terms of RK kasi kanina in terms of heat output yan tsaka heat input. Ngayon naman in terms of RK, so that was the formula is E is equal to 1 minus 1 over RK raised to K minus 1. Where K, of course, is the ratio between the specific ratio at constant pressure and constant volume. So kapag air naman, usually K is equal to 1.4. Depende na lang kung may other given sa problem. Usually lalo kapag cold air or hot air ang pinag-uusapan. So may 1.4 doon, may 1.3 doon, and tingin ko may encounter natin to later. So this formula has, siguro maglagay ako ng another video for this to derive this, to be derived. Pero as you can see naman, tingin ko kayang-kaya nyo rin itong napalabas. So this is the efficiency in terms of RK. Of course, let us proceed sa iba, mga minor ano na to. So percentage clearance. So tingin ko kailangan talaga maggawa ng another video for derivation of this formula. Pero let us just take a recap on this formula. So percentage clearance, so this is represented by C is equal to 1 over RK minus 1. So that was the percentage clearance. And of course, volume displacement. Volume displacement is just, pwede natin represent by VD. So volume displacement, just the difference between the two volumes. So that was B1 minus B2. Or pwede rin natin sabihin B4 minus B3 because B1 is equal to B4 and B2 is equal to B3. Kasi nga ang process mo is SB, SB. Dalawang volume lang ang involved and dalawang isentropic. Okay? Of course, if we have a percentage clearance and volume displacement, meron din tayong clearance volume that represented by VC, and that is equal to the clearance or percentage clearance multiplied by the volume displacement. Of course, clearance volume is in cubic meter then, or cubic feet, or whatsoever volumetric unit. And of course, mean effective pressure, that was represented by PM, and that was the ratio of the network over your volume displacement. And if you multiply or cross multiply this one, that was basically work is equal to P. So that represents the work is equal to pressure times volume. And since you are asking for mean effective pressure or pressure, of course, just divide it both sides by V. So doon mag-a-appear yung ratio of work over volume. So that's all for the formula for this Otto cycle. And syempre, proceed tayo sa problem solving. Okay? So, but before that, I will just get my calculator. So, iisa-isa natin yan. So, gusto ko mang magdagdag pa ng maraming sample, but recapping of formulas, talagang doon tayo nagtatagal minsan. So, I will try to lessen that one. So, this problem comes from the book of Simangan Affairs. So, kung meron kayong mga book, pakitignan na lang yung sagot natin kung match. Okay. So, lagay muna natin solution. Okay, so an Otto cycle daw with a compression ratio of 7.5 operates from the suction conditions. So, guhitan na natin yung mga mahalaga. So, this is compression ratio of 7.5. Lagay na natin. Operates from the suction conditions 97.91 kilopascal absolute. So, pag sinabing suction, of course, this is your first pressure. So, pressure 1. Kilopascal absolute. Okay, and of course, may kaakibat na temperature. So, that was the suction temperature, 29.4 degrees Celsius. So, ang sabi, find the pressure and temperature at the end of compression, meaning they are talking about the P2 and T2 kasi yan yung end of compression. So, let us draw the graph again. So, that was, yeah. So, this is your point 1. So, this is isentropic compression. Of course, this is isovolumic. So, 3 to 4, that was S is equal to C. And of course, this is an isovolumic again. Okay. Of course, we have this given pressure 1. So, meron tayong given a pressure and temperature at point 1, and we are looking for the value of pressure and temperature at this point 2. Of course, meron din tayong given na compression ratio. And syempre may challenge. Kung nakikita nyo ang tanong natin sa A at B, if cold air is the working substance and B, if hot air is the working substance. So this is not a difficult question pero medyo matagal nga lang isolve. Okay, so RK natin is 7.5. Ang ating pressure is naka-absolute na so there's no need for conversion. This T1 is only on Celsius so we need to convert it in Kelvin. So 29.4 plus 273 is equivalent to 273 plus 29.4. So that was 302.4 Kelvin. Pwede rin 273.15. Pero nakasanayan na natin na that was 273. So proceed tayo for answering the question. So hinahanap is a pressure and temperature at the end of compression. So umpisa natin sa A. Nasabi if cold air. So cold air meaning K is equal to 1.4. So in order to get the pressure 2 and temperature 2, what formula are we going to use? Okay, so kanina sa recap natin ng formula, I forgot to mention the PBT relationship. So PBT relationship. So this is applicable itong sasabihin ko mga formulas, lalo na kapag isentropic ang process. Since we are looking from point 1 to point 2 which is isentropic compression, of course, the relationships for P, B, and T are, of course, isentropic. Okay? So, para matandaan natin, madali, we're going to have a basis or reference. So gagamitin natin reference is pressure. So that was the ratio of two pressures. Okay, so pakitandaan na lang itong formula nito. Pressure 1 over pressure 2 is equivalent to volume 2 over volume 1. Raise natin sa K. Yan. Yung K natin is 1.4. And of course, we have this temperature of T1 over T2. And that was raised to K over K minus 1. And of course, since we are looking for pressure 2 and temperature 2, at may given tayong pressure 1 and temperature 1, so unahin na natin siguro, ano pwede natin unahin? Kung pagtatapatin natin si pressure 1, pressure 2 is equal to T1 over T2 raised to K over K minus 1. Meron naman tayong pressure 1, meron tayong temperature 1, meron tayong K which is 1.4 ang problema. Wala ito, wala ito. So where are we going to go? Okay, so kung natatandaan nyo kanina, meron tayong compression ratio which is also equivalent to B2 over B1. Which is exactly na makikita mo itong itsura na ito dito. Ibig sabihin, pressure 1 over pressure 2 can be also equivalent to RK raised to K. Which is given parehas. Ito ay 7.5 and this is 1.4. And of course, meron kang pressure 1 which is 97.91 divided by pressure 2 and that was equivalent to 7.5 raised to 1.4. So we have a pressure 2 which is 7.5 raised muna sa 1.4. Then 97.91 divide mo yun. Tama ba? 97 point. Dapat ay Teka, dapat lalaki ito. So that should be, no, baliktad. Hirap pag galing ano yun. Pag galing ibang mundo uli. Tama to, tama. Ang mali ay eto. Teka. No, to, tama. Dapat mas mataas ang nasa numerator mo. So this should be B1 over B2 at dapat babaliktad ito. So this should be 1 over RK. So, and sorry for the misunderstanding. Sabi sa inyo, matagal akong nawala. Medyo kinalawag na rin tayo. So that was 1 over 7.5. Kasi dapat lalaki yung pressure to mo. Kasi as you can see here, nag-compress ka. Of course, your pressure will go higher. Sa diagram, obviously, pressure 1 is less than pressure 2. So that was 1 over 7.5 raised mo sa 1.4. Of course, this should be less than 1. And 97.91, divide my answer nun, and you will get 1644.04 kilopascals absolute. Okay. So meron tayong pressure 2 para sa 1.4 na K. And of course, we are looking for temperature 2 naman. And since meron na tayong ratio nito, pwede natin tong panindigan. So, pwede rin naman nating itapat na lang dito. So, B2 over B1 raised to K, or 1 over RK raised to K is equal to T1 over T2 raised to K over K minus 1. So we have the 1 over 7.5 raised to 1.4 is equal to T1, which is 302.4 over T2. So that was 1.4 over 0.4 kasi 1.4 minus 1. So we are going to have a second temperature of, pwede nyo rin namang i-shift solve. So that was 456.21. Tama ba? Parang mababa. Parang nabababaan ako, guys. Pero dapat yan ay sige, tingnan natin. So that was ulit. Baka mali lang. Pwede natin pressure 1. Teka lang, guys. Ito talaga pag galing ibang mundo. Ito, tama na ako dito. Teka, ba't ganun? Tama naman tayo ng relationship dito. Pwede natin makancel na ito. Okay, tingnan natin sa okay, tama naman tayo. Tinignan ko sa libro yung sagot. Kung tama ako. So this is correct. Okay, so ang ating answer ay 677. 677.03 Kelvin, or minus natin 273. So in Celsius, that was 404.03 degrees Celsius. Okay, so para may reference ka, o kung nanonood ka sa cellphone or sa laptop, you may screenshot the answer. So tinignan ko siya sa book. Letter A is 1644 kilopascals absolute, and in degrees Celsius that was 404. So tama ang ating tinatahak. Okay? So letter A lang pa lang to. So letter B, sabi daw if hot air is K is equal to 1.32. So we're not going to erase this full scenario or just to repeat the 1.32. So let us just replace this as 1.32. Kasi yun lang naman ang nagbago. So syempre magbabago rin ang value nito, pero yung unit hindi. Okay, so 1 over 7.5 raise mo sa 1.32. So that was 97.91 divided answer. So the answer is 1399.3 kilopascals absolute. Pero ang sagot sa book ay 1.4 sakto. Pero pwede nito. Kasi naka 0.15 siguro si Fairs sa kanyang temperature. So tayo 273 lang kasi. Pero this is acceptable also. So that was 1399.3 kilopascals absolute. And again, since this is cancel na yung itaas na yan, pero lalagay pa rin natin. So that was 1.32, 1.32, and this will be 0.32 kasi 1.32 minus 1. So of course, magbabago ito, magbabago ito. Okay, so our answer is, cancel na natin to para madali. So 1 over 7.5 raise mo lang sa 0.32 kasi mapupuntang kapila. At yung answer na ito ay divide mo sa 3 or 2.4. So you're going to have a 576.24. Of course, minus mo ng 273. So you're going to have a 303.24 degrees Celsius, which is, if I look on the book, okay, so the answer is 3 or 3.3. Malapit. Okay, so we already solved the A and the letter B. So ang natitira na lamang is ideal thermal efficiency based upon the conditions given in A and B. So we're going to remove just a little portion banda rito in order to not erase the whole scenario. Kasi meron naman tayong shortcut formula. Okay. Okay. So letter C tayo. So we all know that the thermal efficiency based on the conditions given, meron tayong kaninang second formula for the thermal efficiency, which is 1 minus 1 over Rk raised to K minus 1. Tama ba kung babalikan natin? Ayan siya. So Rk raised to K minus 1. So this will be easy and direct substitution. So that will be 1 minus 1 over 7.5 raised to 1.4 minus 1 kasi 1.4 yung cold air. So we're going to have an efficiency of course, times mo sa 100 yan after. 1 minus 1 over 7.5 raised to 0.4. So that was 0.55. 33. Of course, times mo siya ng 100. So that will become 55.33%. Okay, so of course, just substitute. Palitan mo lang sa calcu mo. Lagay na natin ng 1.4. So ito naman sa 1.32 in order for us to save time and save space. So palitan mo lang yun. So that will be 0.32 kasi 1.32 minus 1. So that was 40.475. times 100, of course, this is 47.5%. Of course, the lesser the ratio of your specific heat, the bigger the efficiency. Okay. So that's all for the Otto cycle and its introduction for the internal combustion engine. Sorry kung medyo naglag tayo konti kanina. Sorry sa inyo, kakabalik ko lang din. Pero at least pag nagtuloy-tuloy ito, I hope it helps you a lot in your review sa darating na February mechanical engineering exam. So our next, titingnan ko kung makagawa pa ako ng another problem for this kasi nangangain talaga ng oras. Pero of course, obviously the next topic is the diesel cycle, tsaka yung dual cycle and other power cycle. So thank you guys sa pakikinig. Good luck and God bless. See you on our next video. Bye-bye.